We have the first raw images of interstellar object 3I/Atlas, but only because Mars was watching when every Earth-based telescope went blind. On October 3rd, as this cosmic outsider skimmed just 0.2 astronomical units from Mars, our planet's entire fleet of observatories slipped behind the Sun and into darkness. Now, with official agencies silent and only a faint blur dredged up by amateur astronomers on Mars's surface, the most mysterious object in the solar system moves unchecked through a blind spot no one expected. Why has NASA vanished from the conversation? And what are we really missing about 3I/Atlas while the solar system's most extraordinary visitor slips out of view? On October 3, 2025, 3I/Atlas swept past Mars at a distance of just 0.2 astronomical units, about 30 million kilometers, or roughly 18.6 million miles. For a cosmic traveler, that's a near miss. To put it in perspective, that's less than 1/5 the distance between Earth and the Sun, and closer than Mars ever gets to our own planet during its orbit. In practical terms, this flyby meant that every camera and sensor orbiting Mars had a front-row seat to a visitor from another star system, a chance that comes along maybe once in a generation. NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, China's Tianwen-1, and the UAE's Hope probe were all in position, each with instruments capable of picking up faint traces of an object moving at interstellar speed. Even the Perseverance Rover, parked on the dusty surface, could snap long exposure shots of the sky. The geometry was perfect. As Earth rotated into the Sun's glare, Mars was offset just enough to keep 3I/Atlas in clear view. This rare alignment made Mars the only vantage point for direct observation, while Earth's telescopes faded to static. The numbers alone, 0.2 AU, 30 million kilometers, don't just describe a close pass. They set the stage for why every eye on Mars mattered, and why, for a brief window, the red planet became humanity's lookout post on the edge of the unknown. Only 3 times in recorded history has an object from another star system been confirmed passing through our solar neighborhood. The first, 1I/Oumuamua, startled astronomers in 2017 with its odd shape and unexplained acceleration, sparking debates that stretched from icy comet to alien probe. 2 years later, 2I/Borisov arrived, unmistakably a comet, trailing a bright tail and venting gases as it whipped around the Sun. Now, 3I/Atlas joins this extremely exclusive club. Its path is hyperbolic, meaning it isn't bound to our Sun and will never return. The odds of catching such a visitor are vanishingly small. Hundreds of thousands of comets and asteroids orbit within the solar system, but only these 3 have been proven to come from beyond. Each one offers a fleeting sample of material shaped in another star's nursery, billions of years and trillions of miles away. The scientific stakes are enormous. Every measurement, speed, composition, how it reacts to sunlight, adds to a picture of what's out there between the stars. Unlike Borisov, which was quickly identified as a comet, or Oumuamua, which defied easy explanation, 3I/Atlas gives researchers a chance to study a true interstellar traveler with more advanced instruments. But that window is always narrow. These objects move fast, and by the time they're spotted, they're already on their way out. The rarity of these encounters means that every available telescope, every sensor, and every scrap of data becomes precious. As 3I/Atlas streaks through the solar system, astronomers scramble to gather whatever they can before it slips away forever. Simon Shimoff and Louis Weingarten, known online as Astronomy Live, didn't wait for official word from space agencies. Instead, they turned to the raw image feed from Perseverance. Thousands of unprocessed frames uploaded daily from the Martian surface, open to anyone with patience and the right tools. With Mars facing 3 I/Atlas while Earth's view faded, they started pulling every night sky exposure they could find, focusing on the dates just after the close approach. Each image was noisy, streaked with cosmic rays and the faint glow of Martian dust, but the timing was perfect. By stacking more than 30 long exposure frames, aligning each one to the predicted path of 3 I/Atlas, they managed to filter out most of the background clutter. What remained was barely there, a faint greenish blur, exactly where orbital models said the object should be. The result wasn't a glossy magazine cover, but it was real. The first public image of an interstellar visitor, captured not by a billion-dollar probe, but by 2 amateurs working from their laptops. Their process, painstaking, methodical, and open, offered proof that even in a blackout, curiosity can still find a signal in the noise. Official channels stayed quiet. Even with every major Mars orbiter in position, not a single high-resolution image of 3 I/Atlas has been released by NASA, ESA, or their partners. The Mars Reconnaissance Orbiter's high-rise camera, capable of pinpointing objects smaller than a car from orbit, remained silent, its data pipeline stalled. The reason isn't just technical. The ongoing U.S. government shutdown has frozen most science operations, halting the teams responsible for processing and releasing new Mars imagery. Automated raw uploads from Perseverance continue, but anything that needs human review sits in limbo. ESA's Mars Express team has hinted at faint detections, but nothing definitive has reached the public archives. In the vacuum left by official silence, confusion spreads fast. A routine Perseverance frame of Mars's moon Phobos was passed around social media as a possible Atlas sighting, racking up thousands of shares before astronomers stepped in to correct the record. The public, hungry for answers, is left to sort rumor from reality, while the agencies that could clear the air remain out of reach. Earth's window slammed shut on October 21st, when 3 I/Atlas slipped behind the Sun from our point of view. This isn't just a minor inconvenience, it's a hard wall in the sky. For the next 6 weeks, no telescope on or near Earth, not even Hubble or Webb, can see past the solar glare. The geometry is simple. Atlas is now on the far side, lost in blinding sunlight, and there's nothing we can do but wait. Astronomers mark these periods as superior conjunctions, when the Sun blocks our line of sight to objects near its position. Until early December, all observations are predictions, not measurements. The object could brighten, fragment, or drift, and we'd have no way to know. Most expect it to behave like a normal interstellar comet. But with the data feed cut off, every gap invites speculation. Some even ask, half seriously, if this blackout is hiding something artificial. But right now, the only certainty is uncertainty. The universe isn't just vast. Sometimes it's simply out of reach. 3 I/Atlas will reach perihelion on October 30th, passing about 1.4 astronomical units from the Sun, roughly 130 million miles out. That's the moment when solar heating should push the comet to its peak activity. But even then, it's expected to be between 10,000 and 100,000 times fainter than the usual targets for Mars orbiters. Tracking something that dim is a challenge, even for the best hardware on Mars. When it reappears in December, scientists will be watching for 3 things: its position, its brightness, and whether its shape or motion shows any surprises. All the models say it should follow a predictable arc, but if the numbers don't add up, that's when the real questions begin. No matter how much hardware we launch, there's still a blind spot in our cosmic surveillance. Not a single telescope sits on the far side of the Sun, ready to catch what slips behind the glare. For years, mission planners have floated proposals for solar-opposite observatories at Mars orbit, at Lagrange points, even free-floating in deep space. But none have made it past the drawing board or the budget committee. So as 3I/Atlas vanishes from every Earth-based eye, we're left hoping for a workaround. Some looked to the European Space Agency's JUICE probe, now outbound toward Jupiter, but its cameras aren't built for faint, distant targets like this, and there's no plan to retask the mission for a comet cameo. The gap is real, and it's a policy choice as much as a technical one. Until someone funds a true interplanetary network, these periods of total blindness will keep coming. On October 3rd, 2025, 3I/Atlas passed just 0.2 astronomical units from Mars, the third confirmed interstellar object ever recorded. As Earth's telescopes fell silent behind the Sun, only Mars-based assets remained. But the first images came not from official channels, but from two amateurs using Perseverance Rover public data. Despite thousands of images captured and analyzed, no agency has released direct, high-resolution observations to date, in part due to a U.S. government shutdown and standard data release delays. The object's trajectory and brightness matched predictions, but its true nature remains unconfirmed. For now, 3I/Atlas will be invisible until early December, leaving critical questions unanswered about its composition and origin. This event exposed a clear vulnerability. Without interplanetary observation networks, humanity faces weeks-long blind spots during key cosmic encounters. The facts show that even with advanced technology, our cosmic awareness is not complete. And 3I/Atlas reminds us that the search for answers continues.